jump into a couple of slides first. Some of this we touched already in the intro chat, but yeah, we're gonna just talk briefly about what entity resolution actually is, what is the problem, why is it important, a quick overview of some of the methods that are available in Neo4j for solving the issue, and then finally the practical application. So entity resolution, it's determining whether or not two representations of an entity actually refer to the same entity. So again, as we mentioned before, if I was going to extract some entities from some data related to Amazon, for example, I might end up with two nodes, Amazon and separately Amazon Inc. But of course, these two should be considered the same entity, so that we have consistency in our graph, and all the information related to Amazon is in the same region, in the same center of the graph. So that's the problem in a nutshell. As I also said, not a new problem, newly relevant because of the possible applications of extracting graphs with LLMs from unstructured or semi-structured data. And it's important because, yeah, if you have your duplications of your entities and your information scattered between those entities, it's going to definitely limit the quality of insights or quality of just the usability of your graph, quite obviously. Some methods, starting at the top, the dream case, wherever you can apply it. The simplest way is just business rules. In other words, if you can say that if we have two user nodes with the same phone number, then we are going to consider them the same user. If we have nodes of our offices in different locations, if they have the same address, we're going to consider them the same office. Beyond that, we have semantic similarity, which is going to be very familiar to anybody who's worked with RAG. So just vector embeddings of node properties, and then running semantic similarity on those vectors. So if we have a node with a company node with a name Tesla in the industry of autonomous vehicles, that's going to be similar as another one with the self-driving cars and Tesla Inc. And then the third one is more specific to graphs. And this is going to be structure-based similarity. So not just the properties of the nodes, but actually the relationships of the nodes. So if we have shared relationships or the same relationships between nodes, then we can also compute similarity based on that. So for our Amazon example, if there's a relationship has headquarters in Seattle or has a subsidiary AWS, was founded by Jeff Bezos, and if they share some of these relationships, then we can also leverage that in our similarity calculation.
Cool.
And that's the intro. Now the demo. So very first, we're just going to look at a very simple graph. And we're going to use this to show these methods that I mentioned, mainly structural similarity and semantic similarity in action. See how they work, how you can use them in Neo4j. So for this graph, we just have some doctors contributing to projects and working in a field or department of medicine. And the very first thing we want to do before we run any graph algorithms is create a graph projection. And for those who aren't familiar or are less familiar with Neo4j or the graph data science library, graph projection is like a saved temporary subsection of your graph. If you're familiar with relational databases, good analog is something like a database view. So you can save a view of your database or some section of your database. And that's useful because, first of all, you can specify which nodes and which relationships you want to include in the projection, so you can narrow the scope for which you run the algorithm. But also more generally, you need to define, even if you want to include all of your graph, you need to create the projection first, because you can only run the algorithms on these projections. So we're going to do that, including all our nodes and all our relationships. We can also specify the orientation of the relationships in our projection. So if it's undirected, then that means that the projection isn't going to carry any information about the directions of the relationships. It's just going to have the information that there is a link between these two nodes, for example. But if we change it to natural, then it's going to preserve the original directionality as well. But here we're just going to set it as undirected and create this projection. With the projection created, we can now run this quite simple node similarity algorithm, which you can find the details of in the Neo4j documentation. And this just computes a similarity based on the shared relationships and shared neighbors that the nodes have, and doesn't take into account anything else. So for our example, these are the scores we are getting. And just to put that in the context of the graph itself, the highest score we are getting for these two, Dr. Baker, Dr. Clark. And that's unsurprising because they do share two of these relationships. They both work in oncology. They both contribute to this same project. Now, the reason the similarity isn't perfectly one perfect similarity is that Dr. Baker also contributes to this other project, which isn't shared by Dr. Clark here. So that's just the basics of node similarity. And for the second one, which is the node embeddings, for that we're actually going to jump into VS Code. And the reason for that is that we are going to actually use OpenAI's ADA2 for the embeddings. And you can create embeddings in Neo4j natively as well. There are some embedding algorithms, namely what is it called? Fast RP. Yeah, fast random projection, which allows you to calculate embedding based on, you can include relationships, you can also include properties. So that is definitely an option in Neo4j native. But for a few reasons, one being that I'm just personally more comfortable with Python. But the second reason is also that just to demonstrate that you can actually also use any kind of embedding model that you want with Neo4j. And as you'll see in a moment, I think entity resolution is actually a case where it might be useful to have a fine-tuned embedding model. But just to show what we are doing here, we are just getting all the doctors in our graph here. And for each of those doctor nodes, we're going to get the text of the skills property, which all the doctors have. They have some set of skills. And this is what we're going to base our embeddings on. So we're going to embed those through the OpenAI endpoint. And then we're going to update each node with a new property embedding and set the value as the embedding. And now, if we reload our graph, in my notebook, I had a section for creating the graph, so now we have it double. But the point is that now we have this new property of embedding for each doctor. And whether you get that embedding from one of Neo4j's embedding options or something else, once you have that, then you can run the cosine similarity from the GDS library to get a similarity score based on the embedding property. And it's messed up a little because of the duplication I just created. But the main thing here is that for Dr. Clark and Dr. Baker that we looked at earlier, the cosine similarity of their skills is going to be exactly 1. because we have given them the exact same skills here. So we're going to have perfect similarity. And then it's just going to go down for the other ones. Now, generally, you'll see that all these scores are pretty high, although a lot of the doctors do actually have very different skills. And the reason for that is that we are using a generic embedding model, which is what Ada 2 from OpenAI is. And that means that although in the specific context of medicine, some skills might be very different, but for a generic embedding model, they're still all like medical terms. And as a baseline, they're going to get high scores, high similarity scores. And so that's what I mean when I say that a fine-tuned model might be useful for this kind of use case, because it is like we are quite sensitive to like subtleties in a certain type of similarity or difference in our values. So yeah, fine-tuned embedding model for this to get more precise similarity scores might be useful here. But that's just to demonstrate how these work, node similarity, and cosine similarity in Neo4j. But now we're going to look at a slightly more realistic graph, which I have loaded here.
Maybe before we before we do that, there were a couple of points. Oopsie, let's do it like this. That came up in chat, so maybe we take a short break here. A good comment from Mark came in chat that is using Neo4j's vector search to find similar nodes and then subject those to rigorous pairwise logic. The ANN search does a fantastic job of reducing the number of pairs to compare, and he showed this in a session at Nodes 2023. I linked that one in the video description. So if you want to know more about that, then you can find that in the YouTube video description. Himanshu says, what I'm really interested in about is how graph structure is going to help in doing dedupe, because other things can be done with other things.
Mm-hmm.
Yes, I guess that's something we're gonna show next, right? So that's like a look into the graph structure. So that's perfect. And then maybe quickly for Alex, I think it was answered, but just for everybody else, what kind of embeddings did you use? Text embeddings, node properties, or graph embeddings such as Node2Vec? I think you ended up using text embeddings, but
yeah, so there's a variety of options. Like you can use the node similarity algorithm for the relationships, and then you can separately do text embedding, or you can also do something like Node2Vec, which or fast RP, which allows you to create the embeddings based on both. What we are gonna look at in the next part is actually combining these two approaches that I just showed into some kind of like combined similarity score that we can then use for the deduping.
Cool.
But yeah, there's a lot of different options.
Yeah.
So it's just boils down to what suits you the best.
Personal preference. Yeah. That makes sense.
And what works the best.
What works the best? Yeah, of course. Yeah. Cool. All right. Yeah. If you continue with the questions, then I'll read them out as we go along. But I didn't want to interrupt your demo just while you were talking.
Yeah. No. Awesome. Feel free to interrupt me. I can steam through pretty fast.
Cool. Now I lost your screen, I think.
Oh yeah, I'm gonna redo it.
Yep.
All right.
Oh, there it is. Perfect.
So this time we are looking at a graph of Amazon and its various subsidiaries, as well as their services, some key people involved, etc. And it's been partially extracted from some Wikipedia articles about Amazon and AWS and Zappos mainly. But I will also say, in terms of transparency, I've also done quite a bit of post editing in order to make it more suitable for the demo. But for our purposes, what we are especially interested here is the fact that there are, in fact, two versions of Amazon here. We do have our Amazon and Amazon Inc., as I alluded to before. And we also have separately Amazon Web Services here and AWS here, sharing some of the edges and some of the properties. So we're going to jump back into VS Code. And we're going to try and see if we can apply the methods covered previously and try and detect these duplicates and then get rid of them. So again, the first step is going to be creating the graph projection, selecting all the nodes and some of the relationships that are relevant. And we're going to start by just running the node similarity on its own. And we're going to convert the results into a data frame. And indeed, because our duplicates here do share a lot of the edges, we do get high scores for them. Additionally, we can also see that we get some similarity for Amazon Fresh and Whole Foods, which is also not that surprising because they also here share some properties, both offering groceries being owned by Amazon. And but this again highlights the, I think, importance of not just relying on the structure itself, because that can be shared across nodes. But in fact, if they are different in other ways, in their properties, for example, and then that's going to be important to capture in our logic as well. So for the embeddings and the cosine similarity, the process is also going to look similar as in our previous dummy example, except that this time, instead of just taking one property, which was the skills property of the doctors, especially if we are working with a graph that's partially extracted from unstructured data, we might not always be sure what properties each node has. So for our embedding text string, we're going to join all the properties that a node has, regardless of any arbitrary amount of properties or their names that their node might have. And then we join that into a text string. And then this text string is the one we embed, again, setting it as a new embedding attribute. And so we're going to run that. And then once the embeddings finish computing, then we're going to run the same cosine similarity function from GDS. And now we also get the scores for these nodes.
Can we zoom in a little bit into this one?
Oh, yeah, please.
Yeah, cool. Thank you.
Might also do this. Yeah, and so this is a bit of a gamed example in the sense that being such a well-known company, even the generic embedding model is going to recognize that these two are very similar. So it is going to give us very high similarity scores for AWS and Amazon Web Services. One point here is that we also get a very high score for these two Amazon Books and Amazon Web Store. And what that tells us here is that, if I can find the two nodes, we don't have a lot of properties for them. Like all we have is this industry and a name for each. And of course, the fact that there's Amazon in the name and the industry is quite similar, it makes sense that the cosine similarity is going to be quite high. But what this tells us is that, and I'm going to mention this later as well, but one thing I found is that the quality of your extraction really influences the quality of your entity resolution a lot, because the more properties you can extract in the early stage of your graph construction, that just means that you have more to play with when it comes to entity resolution and defining the process for your entity resolution. You'll have different attributes for differentiating different nodes. And Whereas if you just have a very limited amount of information, then it's going to be, then the nodes are either going to be completely different or completely similar. Like all the companies in one industry, for example, might show up very, very similar in your efforts to do entity resolution. And it can be difficult to actually differentiate them in the way that matters. Now, with the cosine similarity and the node similarity, what we now want to do is we are going to combine them, as I said, into one score in a very simple way in this case. But here again, like you could have, and you probably would have, a lot more, let's say, nuance to how you actually calculate the final score. You could do a mean, you could do a simple multiplication as we've done here, but you could also add weights to one aspect of the scoring, depending on what you think is gonna give you the most signal about the duplication. So that's something that you'd also have the option to think about here, how to do best. But for this demo, we're just gonna do a very simple multiplication, getting us this combined score, which just in a very simple sense combines both the node similarity based on the structure, but then also the cosine similarity. And after that, however you get to that final stage, whatever your process looks like, what the deduplication is typically going to look like after that is simply setting some threshold or some rule for you to decide that two nodes are in fact the same. And here we are going to use this same as relationship that we're going to create between two nodes once we do decide that they are the same. And we're just going to use this unusually low threshold of 0.20, but it's going to work for our purposes here. And then we are going to iterate over all the rows in our data frame, see which node pairs have a similarity score above our threshold, and then we can create the same as relationships. And now we can see that now these two nodes are in fact tagged as being the same. And so with that in place, the last thing we need to do is we just need to merge the nodes that have the same as relationship in this way, finding the node pairs that have the relationship. We're going to delete the same as relationship right after that because we don't need it anymore and we don't need it to be cluttering our graph beyond this step. And then for all those node pairs, we're just going to use the APOC refactor merge nodes, which is going to combine these node pairs and merge the relationships as well. And that's going to be the end of our deduplication process, basically. But here again, although it seems simple here, but in reality, this is another point where you would have to do some consideration because, okay, you have your two nodes that you want to merge, but if they have conflicting properties, for example, they have different emails or whatever else, different properties or different relationships, which ones do you want to prioritize? Because essentially you're going to have to choose one node to keep and one node to delete, and then just how you choose that node, whether you want to use some kind of creation date or updation date and select the newer one or maybe the older one. In reality, that's also a consideration that needs to be made at this step. But now if we run this, then the end result should be indeed that we no longer have Amazon Inc. And then we also don't have AWS here. And that's basically the end of the demonstration. I would say it is like, as I mentioned, it is sadly almost a bit of a still a simplified example, because in reality these processes would be very, let's say, multifaceted and very elaborate. And it's also difficult to come up with a data set that can match that while also being simplified enough to be followable in a demo.
Yeah.
But hopefully that gives you a basic idea of how you might approach this problem.
Cool.
And with that, I just have a few more
Yeah.
final remarks here, and then we can use the rest of the time for
Cool.
some
Absolutely.
Q&A.
Yep.
I think I covered most of these already before, but yeah, as I said, better extraction, better resolution. The more you can extract good data earlier in the pipeline, the better your options are going to be, and better your results are probably going to have in the resolution. Particularly if you can find ways to find these kinds of unique identifiers in the extraction phase, whether it's emails or phone numbers or some stock tickers, stock symbols, something that you can use to anchor entities as being a particular type of entity. That's really going to help your process later on. And yeah, this I said to Tomas at the very beginning. The reality is that it's here we deduplicated companies, but in a real scenario, we would probably also have duplicates of people, duplicates of services, duplicates of brands, and we wouldn't be able to use the same logic, the same properties, the same embedding configuration for one node type that we can use for another. So in reality, you'd probably have to define this kind of a process of steps for as many different duplication problems that are going to happen in your particular graph, and then just find a way to also run those in some particular order, because the order is also going to matter. Because every time you merge some nodes, you resolve some entities, it's going to change the structure of your graph. And then if you use that structure to compute similarity for some subsequent steps, then the order of the steps is also going to be important. Final note is that LLMs, I think, also can be one useful tool in this step, as well as the extraction, but also the resolution. Like, it's obviously not feasible to just feed your entire graph to an LLM and ask it to spot duplicates beyond a certain size of a graph. That just obviously isn't feasible. Anytime you want to update some data is to feed the whole graph to an LLM. But if you do use methods like the ones I described here to narrow down the scope of, okay, here we have some potential duplicates in this section of our graph, then maybe that smaller slice you can then pass on to an LLM for also some further, let's say, validation or further analysis to help highlight those deduplicates or those duplicates. So some combination of like that. I haven't worked with that myself, but I think if I was going to make a video continuation on that, I think that would probably be a significant part of it. So, thank you.
Cool. Thank you very much, Johannes. That was cool. That was good to see, good to hear, and thank you for the demo, especially that made it all a little bit more real life, I would say. So that helped a lot. There were a couple of questions in chat I'd like to talk about. I think they are interesting ones. So Alex asks, any suggestions for metrics that might be used to help identify a threshold? So I think what they mean is when do you think a similarity score is high enough that you would say, okay, this is now good enough to deem a merge? And in your case, it was pretty clear. You look at AWS, you look at Amazon Web Services. Okay, this makes sense, but the Whole Foods and Amazon Fresh example was like, okay, yeah, there is some similarity there, but maybe not enough. Do you have some experience on that? Do you have some ideas of how to approach that?
I'm trying to avoid giving the cop out answer of it depends, but
Yeah, but it does, I guess.
yeah, the reality is that I think the key factor there is that like our threshold here was set very low, but in a different kind of graph, you might have just a baseline, a lot of similarities between entities as a baseline, a lot of shared structure, shared properties, without that indicating necessarily that they are duplicates. Whereas in another one, even one or two key relationships, like for example, if it's like one of these very high signal relationships, like having a certain CEO or having a certain product, that might be like a dead giveaway that as long as this one relationship is shared, the threshold can be very low. If that makes sense. I think, yeah, it just comes down to how much similarity there is between your entities as a baseline, and then you are looking for the outliers beyond that baseline. But if your baseline is already like very low and there isn't a lot of similarities as a rule, then even small deviations above that baseline might indicate that there is a duplicate there.
Yeah. Do you think it might help to add vector search on top of the node similarity, or the looking at the graph structure, and add another tier to it? Is that something that would be helpful?
I mean, in principle, yeah, like all that cosine, like vector search is basically in most cases is just cosine similarity.
Yeah.
So basically, that's already, we aren't doing a search exactly, but we are basically doing the same. The scoring is based on the exact same metric that a vector search would be based on. So in some sense, we are already doing it.
Yeah. Okay. Cool. Thomas, you look like you want to say something.
Yeah, I
Yes,
want
please.
to answer.
I'm eager to hear Thomas's
No, but
speed.
because I'm gonna say first of all, it was this week or last week. I talked with some people who like did submitted to archive, but they haven't published a paper yet, and they did the exact same thing that you did here, which is just basically take the cosine similarity of names and then try to basically just compare the cosine similarity between entities. And then in their case, they took a really high threshold because they would rather have false negatives than false positives, right? So you rather not merge uh, by my by mistake than merge by my mistake, if that makes sense, right? So if that means that two entities, if they're different, they will still be different, but two entities that might be the same might not be merged in that case. So like when you're talking about threshold, it also like depends. You wanted to avoid it, but it really depends what you want to do, and like what's your preference. Are you more strict or less strict? And what I wanted to say is that with like even with entity deduplication, you don't have to merge the final nodes, right? If you say these two are identical, right, based on threshold, you don't have to merge them. You can just leave the same as relationship, and then maybe have like like a manual review that someone who basically like a domain expert who says, okay, this is and this is not, or it could just stay same as forever in the graph, right? Because when you merge the nodes, you kind of lose some of the information, and then you don't really know how to say, if you made a mistake, you will never know that mistake was made because you merged that information, right? So maybe in some cases it makes sense to not merge the nodes at all.
Yeah, that makes a lot of sense.
That's a good point.
And yeah, I mean, like you said, LLMs, a lot of people are using LLMs, but it can be quite costly.
Yeah.
It can be quite costly, and then it depends. Like if you trust an LLM or like how much do you trust an embedding property, and it's like, yeah, I mean, I don't know, but what you could do is, like, for example, use an embedding similarity to find like potential candidates, and then the final step, the authorization is done by an LLM. So say, okay, this is to be merged and this is not to be merged. So that will be like more automated and expensive way of doing it.
Yeah. Is a good comment / question from Peter in chat right now. If entities change over time, is there a best practice for representing that in a graph? Do you once you do the merge, once you decide, okay, these have been duplicates, is there do you want to keep this tracked somehow? Is this something you would put there, or is this something you usually don't?
Yeah, I mean, as you could say, usually I mean, there are best practices for representing changes over time. Like, so you have some versioning based on time, and then it depends how complex and granular they want to be, because you can have like states of each entity, sort of, right? What's the state of entity in like 2020, and what's the state of that entity in 2021? So there's a lot of things you can do, but like my advice would be just try to keep it as simple as possible. Right. Yeah.
Yeah, I mean that's good, and yeah, like you said, it depends a little bit on what's important, and what you want to get out of it in the end. If a full history is very important, then that makes sense to add that. If it's not as relevant, maybe for some reason or other, then maybe keep it simple and cut down a little bit on the overhead. There is another question from Manuel to both of you. What do you think about the idea of applying any of the re-anchor solutions out there to identify high similarity for entity resolution? And he adds, it is true that with low context, nodes and properties sometimes can be very overkill, but I have the impression this could be a good approach for the similarity identification in a first stage. Any idea? Re-anchor solutions. Does that ring any bells?
Yeah, I mean, isn't re-anchor just again some sort of similarity, right? Because I think in RAG applications, when you do re-ranking, is kind of another, so it's not the same. Like, for example, if you do a RAG application, first you, let's say, do cosine similarity with like text embeddings like ADA 002, and you select like top 100 results, and then you do re-ranking to find the most relevant one. So re-ranking is kind of another similarity metric, right? So yeah, I mean, definitely the more similarity metrics, like reasonable and with signal similarity metrics that you can incorporate, the better, right?
Yeah, and also what re-rankers often use is some kind of training data of examples, and that I think ties into what I said about fine tuning in particular. So you could have some training set or test sets of well, it would be I wouldn't want to define that kind of a test set for this kind of application because it would be a lot of work. But if you were going to re-ranking, it's just another scoring process. That's all it is. Applying some conditions. Usually it's just a different kind of embedding. Sometimes it involves some user preference data that we have from a history, results in the context of RAG, results that have been preferential to users in the past. We can use that to re-rank results in the future. So sure, you could apply something similar here, but it's not so different in some sense to the kinds of methods we talked about here earlier. It's in some sense it's just a different name for doing more of the same stuff, like Thomas said.
Cool. There's one more question from Himanshu. For real-life pipelines, though, extracting more properties seem to be better, but these other properties also have high amount of duplicates in them. Any idea, suggestions for that?
Yeah, I would generally say more is better, because you can always choose which properties you can select for your similarity computation. And then if you have more to choose from, then you can probably just try and choose the ones that are most, let's say, most signal, most distinctive of each entity. And in other words, if you compare on those, then that's going to be more of a better results for your similarity scoring. Yeah, it can be problematic if you have a lot of properties that are just shared across the board and can kind of bloat your similarity scores. But I think that's you can set your thresholds higher. You can not select some of the properties that are just going to be shared between the nodes. So yeah, I would still definitely say more is better, and then you can choose which ones to use.
Okay.
Yeah, I mean, I would just add that basically this is a really hard problem that before LLMs, even academia was interested in, and it's not like a solved problem, right? It's just do what you can with the options that you have. And then that's it, because there's also one we didn't mention specifically, but there's also the concept of entity linking. So if you have a target database that you can link your entities to, basically, for example, the most common example is having Wikipedia as your target knowledge base, and then you try to map entities in the text to Wikipedia, right? So that is your kind of disambiguation, deduplication part, where you basically for each entity return Wikipedia ID. And for a long time I was a fan of that, but that's not really a flexible solution, right? Because Wikipedia knowledge base is nice, but now let's say we want to extract internal documents of a company. I mean, not all employees are on Wikipedia and stuff like that, so there's always trade-off. But there's and I think with the entity linking, there are some end-to-end models that you can take a look at, which is quite interesting. So you kind of train a model to do the disambiguation for you based on available options. And yeah, like I said, people have tried a lot of things, and it's not a solved problem. So
yeah, tricky. Maybe
I will also say maybe on a I mean, it's everything Thomas said is true. As a note of hope, I would also say that there is a spectrum of applications here, and it's not just like you always need to get your graph from unstructured data to something that's pristine and consistent and doesn't have duplicates. But often you can lean on like some existing relationship structure in your data. You already have some links that are like known and high quality, and then you can maybe just build on that by adding some extracted unstructured data. And then the problem does become a little more feasible. But yeah, if you are trying to build a graph application from just like entirely LLM extracted data, it's like basically an unsolved problem in a lot of ways.
Yeah, but the good thing is, like you said, that a lot of times we have like a good enough cutoff, and we can say, I mean, it's good enough because even like Google does that. Like I know there are some companies that scrape the internet and kind of do the same thing, and like for the most part, it's fine, right? So like if you can kind of identify what's your like good enough threshold and just try to aim to achieve that, I think it should be fine. I mean, it's gonna take some work, obviously, but it's achievable. Like Johannes said, it's not like uh, you're gonna just waste your time.
Yeah, it's tricky. Maybe we cover one more question before we close. That was sent in from Doron, and they ask, how does this method that you just showed, Johannes, how does that compare with integrity checks in relational database? Are there can you compare it at all? And is there any lessons to learn from using this system or the other system, or is that not really comparable?
Well, I think it's almost more comparable to what Tomas said about having references in your entities, where you can validate the data from the source level. I think that would be like, yeah, that would be maybe the closest equivalent.
Okay.
That comes to mind.
Cool. All right. Yeah, and I think with that, we can close it for today. Thank you very much, Johannes. Thank you very much, Thomas, for joining today, for the demo and for the slides, and for the time, obviously. So that was really nice, and a cool demo and hands-on session. Thank you all for watching this session today. Before you all go, I'd like to remind you that we run a couple of workshops this week, next week, and afterwards, starting with an intro to Neo4j session on Thursday. So we will be conducting these online training series. So if you are interested in joining one of those, more of those, all of them, then check out the link I posted in the chat, or use the one that is visible here on the screen, and suggest you to join one of those if that's an interesting topic. That also means that we will take a little break with Neo4j Lives over the next couple of weeks in favor of this one. So next session is going to be early April, I think, with a Going Meta episode. So until then, we continue doing trainings and all of that stuff. So we'd like to see you there, and join us then. Again, thank you very much, Thomas and Johannes, for your time today and for the presentation. Thank you all for watching, and yeah, I hope to see you soon. Oh yeah, one more question, Johannes. I forgot about this. Is your demo, is this available somewhere? Is there a GitHub repo or some kind of link?
Not yet. I'm gonna try and share it later this week.
Yeah. And if people
And
would like to reach out to you,
I can send it to your way.
Yep.
Maybe I'll comment it on the live stream, YouTube recording,
perfect.
something
Then
like
I'll
that.
add it to exactly perfect. Yeah, cool. Once it's available, then we add it to the video description, and then there's also a means of getting in touch with you, Johannes, if need be. I guess.
Yeah.
Yep.
Cheers. Thank you
All right.
both.
Cool. Thank you very much. Take care.
Bye.
Bye.
Ciao.